All right, we are going to start our last unit. We're technically supposed to have 2 more units, but that didn't happen. So we're going to start our last unit, unit 8, on greenhouse gases and environmental science, essentially. Remember, the second term of the semester is a lot of adjacent chemistry application. This is probably one of the most relevant topics of chemistry that is an adjacent field within chemistry, right? To understand the chemistry of the environment is to understand a lot of why we see the phenomena like global warming and climate change that we do. Now, I do want to preface this unit with the statement that the word climate change has been transformed into a very political word where it just means basically, do you believe in global warming? That's really what climate change has turned into. But just so you know, climate change has always been happening because the climate's always been changing. So we're going to look more at the angle of, okay, trying to see if the evidence, if the data actually points to the way that climate is changing is truly the earth is warming, and see if we can explain why that's the case, if that is the case. So wherever you fall on the political, economic, environmental spectrum on this, totally fine. That's your prerogative. That's your family's prerogative. What we're looking for, though, is given this current evidence, is this something that we can say could be reasonably interpreted as supporting or challenging the idea that the climate, the way the climate is changing is toward warming, okay? But again, climate change is always happening because the climate is always changing, okay? So just keep that in mind. And we're gonna particularly zoom in on one issue that's connected to this, and that's gonna be sea level rise. So the issue that we're going to be addressing is within this idea of climate change is sea level rise, okay? Which is an extent, which is like a subcategory in climate change, right? Because the idea is that if the earth is getting warmer, the sea levels are going to rise. So this is kind of like just a little mini global warming kind of example. We're looking at essentially global warming through the eyes of sea level, okay? And the unit question is, will we lose our Santa Barbara beaches? Or Goleta beaches, or whatever one you want to say. Will we lose our beaches? Okay. So to do that, we're gonna actually just initially look at an actual summary from environmental scientists that have gathered here in Santa Barbara in like 5 years ago. It involved politicians, it involved UCSB professors and experts in the field, it involved consultants, where they looked at some of the data and the reality of the infrastructure of how Santa Barbara is built for the potential concern that sea levels may rise, and if that is even a concern and to what extent that should be a concern. So we're going to kind of take clips from a video. Just listen. It's just to give you context about this is an actual issue that involves political, environmental, social, and economical impact, right? So on top of obviously geographical impact. So let's go ahead and switch on over to, I'll share my screen. Do you want to continue sharing screen? Do you want to continue? Cancel sharing this screen. Do you want to continue? Yes, continue to sea level rise. Sure. Okay, let's move me in the corner. So here we have a video that's annoying.
All of the 19th century, it was the indispensable drawing aid for great masters.
Hello, I'm Melissa Hetrick with the City of Santa Barbara Planning Division, and I'm project manager on the city's sea level rise adaptation plan. The purpose of this presentation is to present the findings of a draft sea level rise adaptation plan that was released and is available for public review and comment on our website, www.santabarbaraca.gov/SLR. To date, sea levels have only risen a very small amount in Santa Barbara. However, sea level rise is expected to accelerate significantly in upcoming years. It's for these reasons that the city's general plan and coastal plan direct the preparation of a sea level rise adaptation plan for Santa Barbara. In addition, sea level rise analysis is now required for coastal development permitting in addition to most other types of permitting and grant funding activities at the state level. Rise occurring off of Santa Barbara.
Sorry. Oh God. Hold on.
For just $67,
Eh,
you can make as many videos as you want. And
I just
never
wanted to
have pick
skip
up a camera or
past.
use
Okay, here we go. Vulnerability assessment. We're gonna look at the risks.
Barbara. These include things such as how the Antarctic ice sheet is melting, thermal expansion of seawater from warming of the ocean circulation patterns, and global greenhouse gas emissions. All of these factors are changing and new information is coming out all the time about how they may change in the future. So what this means is a few things. First, sea levels are not rising uniformly throughout the world. In addition, the farther you go out in time, the more difficult it is to accurately predict sea level rise amounts in any given area. So what the state of California is doing is that every 5 years, they are compiling all the scientific studies and models and updating what's called the State of California Sea Level Rise Guidance, which essentially tells each city and county throughout the state how much sea level rise they should be planning for. This graph shows the projections for Santa Barbara contained in the 2018 state guidance. The lowest line in orange being the most probable scenario, and the red line on top being the most conservative or risk-averse scenario. The city's vulnerability assessment uses the middle line, which projects 0.8 feet of sea level rise by 2030, 2.5 feet by 2060, and 6.6 feet by 2100. This projection is a conservative, risk-averse projection that the state recommends using for comprehensive city planning and planning for permanent structures and development. The state projects that this scenario has a 1 in 200 chance of occurring.
Okay, let's just pause for a second. 2.5 feet more of water for Santa Barbara is predicted on a conservative level. That means they're saying that that is like not the worst case. That's like this is, we should be prepared that this will probably most likely happen. Okay, now we're not getting into how they gathered all this evidence, but we are seeing that this is a huge issue. And so the question is, can we explain the phenomena, the reasons, the scientific principles that create this issue so that we can actually accurately interpret and assess the data? Because a lot of times, if you have a misunderstanding of the science, you will interpret the data differently, right? We know that. People can be given the same piece of data and totally come up with different theories about what it means based on the science they come in with, the science they come as a background understanding. But what they're presenting from their interpretation of the data and their understanding of the science is that this is actually kind of scary figures. Okay, so then when we get into hazard maps, this is fun.
So these are the hazard maps contained in the vulnerability assessment. And I would just note that we have these maps on our website interactively. And so you can actually type in an address and zoom in and see what hazards might be present at a very particular address. This is the west side of the city that is predominantly coastal bluffs. This shows erosion hazards in orange and yellow, bluff erosion hazards for 0.8 feet of sea level rise.
Okay, all those beautiful coastal views. My brother lives on the Mesa. Might not look so beautiful later, but that's okay. You got tidal inundation, flooding. We're not going to get super into that. What I want to do, the last thing to show you is let's look at the beaches.
Along the low-lying and waterfront areas, the beaches will erode much slower, and there's a lot more opportunity to retain beaches through measures such as beach nourishment. This is predominantly due to the
So here she's offering solutions. She kind of went through a series of solutions, and now she's highlighting like, okay, given all the erosion that's going to occur, right? Can we figure out a method that actually slows that down? And she had just offered a method of how to do it. We're not going to pay attention to that.
Topography of the coast in this area. The harbor breakwater helps retain sand on waterfront beaches and also protects not just the marinas in the harbor, but also the West Beach neighborhood and City College areas. The key issue in this low-lying area is the long-term potential for extensive tidal inundation and storm flooding.
So what they're going to introduce is billions of dollars of infrastructure that not only will cost billions to set up, but cost millions to maintain throughout the year. You know that little sand spit in the middle of the harbor? That's not supposed to be there, right? That is partly motivated by all the yacht owners, okay? But secondarily, it is used to actually be kind of a current and flood protectant. That process of keeping that little sand spit of importing the sand and maneuvering it around, because it's not, the currents are constantly eroding it at a rapidly fast rate. Okay. Costs about, I think I heard someone say like a stat of like double-digit millions a year to maintain that little sand spit. Right. So this is an issue whenever you talk about global warming, or when you talk about the potential environmental issues, you got to remember it shouldn't be just about politics. It's about the reality of how a city is built, how lives are lived. And the reality is if you aren't paying attention to your environment, and it will change, the environment's going to change. That's undeniable. Okay. That's not, you're not going to stop the environment from changing. But what you want to be careful of is, and be thoughtful of, is how are we changing the environment? What is the trajectory and what will it cost us? Right? So that's kind of the big idea of this unit, is we're going to look at a lot of the scientific topics that are necessary for understanding why these things may occur. And if they are occurring, how do we understand the data from that? Now, what I want you guys to do is to begin the first subtopic. We're going to hit up several subtopics within this to explain. The first subtopic that you see in your notes is greenhouse gases. You guys have a PhET simulation that you're going to do, and you're just going to start unpacking this question by looking at, well, obviously, when we talk about global warming, the first thing that we all think of is, oh, greenhouse gases, right? Emissions. Let's start there and let's figure out, what are greenhouse gases in the first place? How do we determine whether a gas is a greenhouse gas? So go ahead and go to your notes. You want to go to the digital version, or you can go to my slides on the agenda, and I have a link to the PhET simulation. You're going to answer the following section and fill out the table, and be prepared to answer question 5 and 6 tomorrow. So you're going to do the table in your notes where you look at a series of greenhouse gases. It does come with a lot of little sound effects, so maybe turn off your sound, and complete the simulation in the next 12 minutes of class, and be prepared to talk about question 5 and 6 in your notes tomorrow. All right, guys, good job. And sorry, for those of you that are listening at home, this is what it looks like in your notes. You're going to complete page 1 and page 2 table, and you're going to be prepared to answer questions 5 and 6 based off of the simulation data. So, all right, guys.